Hi everyone, we are excited to share with you more than 20 sample applications that are designed to help you accelerate app development for Qualcomm Linux. These easy to use sample applications are readily available as part of the Qualcomm Intelligent Multimedia Product SDK, which is a part of Qualcomm Linux distribution. You can also find these sample applications on Codelinero. Let's learn more about how you can achieve parallel AI inferencing with Qualcomm Linux. Developers can use Qualcomm Linux to optimally deploy pre-trained deep learning models on Qualcomm Technologies hardware accelerator, such as NPU, GPU, or CPU. There are a few key components that will help you start developing apps for Qualcomm Linux. First, there are AI sample applications that will help you implement end-to-end use cases and can be customized as needed. Next, there are GStreamer plugins. Qualcomm Linux software offers GStreamer based machine learning plugins for accelerating AI inferencing using TF-Lite and Qualcomm Neural Processing SDK. Additionally, there are GStreamer plugins for pre and post processing. Qualcomm Linux applications of this type interact with a specific Qualcomm Intelligent Multimedia SDK plugins, which abstract the interaction with Qualcomm Neural Processing SDK and TensorFlow Lite. That allows you to focus on app development rather than the underlying hardware accelerators. Out of the 4 AI models featured in the AI parallel inferencing, 2 use TF-Lite inferencing and the other 2 use Qualcomm Neural Processing SDK based inferencing. Before we get into the details of inferencing, we will first take a quick look at the entire pipeline. The input stream originates from a live camera feed. It is then split into the 4 parallel streams. Each of these streams is then processed by a dedicated inferencing block for the following use cases: object detection, classification, pose detection, and segmentation. The outputs of all 4 inferencing blocks are combined into a single frame, which is used for display. Now, let's take a closer look at the individual inferencing blocks and see how multiple elements of Qualcomm Intelligent Multimedia SDK are used. Live stream from camera is captured using QTI QMMF source plugin, which is a GStreamer plugin. The live stream input is then passed to the T element that generates multiple parallel streams, which are fed to different inferencing blocks. The QTI vComposer plugin takes the result of all 4 inferencing blocks and combines them into a single stream. Finally, the Valent plugin displays the stream coming from the composer. Each inferencing blocks contain 3 essential plugins: pre-processing, inferencing, and the post-processing. The pre-processing plugin converts the incoming camera frames to a tensors compatible with the model input layers. The inferencing plugin runs the model inference on the hardware accelerator. And the post-processing plugin performs parsing on the output tensors from the inference plugin. Here are the specific models used in the sample apps for the 4 use cases. For object detection, the application uses YOLO-NAS model with Qualcomm Neural Processing SDK for inferencing. For classification, it uses Inception v3 model with TF-Lite for inferencing. For pose detection, it uses the PoseNet MobileNet v1 model and TF-Lite inferencing. Finally, for segmentation, the application uses the DeepLab v3 ResNet 50 model with Qualcomm Neural Processing SDK for inferencing. Now that we have learned about the architecture details, it's time to run the demo application. You will need a Qualcomm Robotics RB3 Gen 2 development kit with the latest version of the Qualcomm Linux and the model binaries, as well as the artifacts loaded to the target Qualcomm Robotics RB3 Gen 2 board. Here's how we run the sample app on the kit. So here's how we launch the sample app and redirect the output to the Valent Sync plugin. Now, let's see the parallel inferencing sample app in action. In the first AI use case, you see object detection that uses the YOLO-NAS model. and inferencing is done with the Qualcomm Neural Processing SDK. The detection and labels are displayed in green. Next, you see the classification results that uses the Inception v3 model, and inferencing is done with the TensorFlow Lite SDK. On the bottom left, you see pose estimation that uses the PoseNet MobileNet v1 model, and inferencing is done with the TensorFlow Lite SDK. Finally, we have the segmentation that uses the DeepLab v3 ResNet 50 model, and inferencing is done with the Qualcomm Neural Processing SDK. Now that you have seen how parallel inferencing works, you can use the tools you have learned to develop your own exciting apps. Please check the documentation for Qualcomm Linux, the Qualcomm Intelligent Multimedia SDK, and the sample apps on our portal. You can also access the source code for the sample apps hosted on the Code Linaro. Thank you for watching.